It deals with polynomial and rational inequalities. Last topic, polynomial and rational inequalities. So now when you talk to anyone, if you ever do, or with your colleagues or you work on MyMathLab, you can say to each other, well, rational functions are way more sophisticated than polynomial ones, or quadratic, for example, or linear. They are used in applications that are way more complicated, not just simply throwing a ball up in the air. Okay, polynomial rational inequalities. Let me show a couple of examples. Let's say we have x negative x plus 1, x minus 3, greater than or equal to 0. And now the question is, what type of inequality is this? It's clearly it's an inequality, right? So what will it be? It's not linear. It's not absolute value. That's all we really reviewed so far. Linear and absolute value inequalities. And compound inequalities. That's all we really reviewed. This is totally new. It should be new. But if you forget about the inequality symbol and you look on the left-hand side, what is that expression? What will you say? It's definitely a polynomial and it's definitely degree 3. Thank you. Awesome. Thank you. Indeed. So this is a polynomial degree 3. Oops. Degree 3. It is a polynomial inequality. Very good. So here is what I suggest. There are other ways, and I encourage you to use the method you like. So there are other ways, but I prefer this one. A table in which x is the variable in the problem. This x is not this x. This x is only the variable in the problem. Now, the next row is the first variable in the problem. The next row is the next variable in the problem. And the last row is the last factor, I meant to say, so forgive me. So this x is the first factor in the problem. This x minus negative x plus 1 is the next factor in the problem. And x minus 3 is the next factor in the problem. The last row is the product, the whole thing. X, negative x plus 1, x minus 3, and I will make a decision. Now, coming back to our inequality for a moment. When is this quantity 0? When x is? When is this quantity? Perfect. When is this quantity 0? Perfect. Excellent. When x is? Good. These are the only numbers we need in the table. We only need 0, 1, and 3. In ascending order, of course. And now I'm going to ask you a couple of questions. And here is the first one. Where will I put a 0 in this row? Under a particular number and only one number, I will have to write a 0. Under? Of course. Where will I write a 0 for this next row under only one number, which is? Perfect. And for x minus 3, I'll do the same thing. What do I get? Perfect. So now I need to know what happens here and here and here for the product. So what happens to the product if the first factor is 0? Of course, if any of the factors is 0 by the zero product principle, thank you very much, the answer is 0. What happens when the second factor is 0 to the entire product? Same. What happens when the third factor is 0 to the entire product? So it's whatever times 0. 0. Now, let's look at the first factor, which is x. Is this a line? Is this degree 1? Is it degree 2? What is it? They're all linear factors. X is a linear factor, negative x plus 1 is a line, and x minus 3 is a line, correct? Okay, so knowing end behavior now, do I graph x like this, or do I graph it like this? Yes. So it will be always negative before it's 0, and then it will become, that's exactly what I need. It's negative before it's 0, and then it's positive all the way. What will be the sign, the sequence of sign for the second one? Remember, everything is in descending order. I look carefully, identify the leading coefficient, or the slope in this case, and say, is it this or is it this? Indeed. We don't have to think, just pick a number if that's easier for you. Pick a number here, plug it in, you'll see it's positive, and then negative. And what about the last one? Exactly, because it's a positive leading coefficient. Now notice one thing. We have how many subintervals? 1, 2, 3, 4. 4 subintervals. In the first subinterval, the first is negative, the second is positive, and the third is negative. I need the sign of the product. I count the negatives. Since there are 2 negatives, I don't ever count the positives. So if there are 2 negatives, what will be the sign of the outcome? Do not count the positives, they are useless when it comes to the sign. What is the sign in the second subinterval? Perfect. What is the sign in the third subinterval? Perfect. And in the last one? Only now I decide what I want. This tells me what I want. What sign is greater than or equal to 0? And that's the one I'm going to pick. What sign is greater than or equal to 0? We have 2 signs, positive or negative. So positive sign is greater than or equal to 0. Okay, so then let's look at the product. Is the product ever positive? It's positive here. For what x values? And it's perfect. It's positive here for what x values? Since it's the equal symbol, I will have to include the zeros. So I will say x in the interval, and please dictate. Closed because of the equal symbol. Very good. Union. Very good. This is it. This is the method of solving polynomial inequalities. Nothing else. What does this mean? That if you pick a number between these two or these two, all this product will be positive. If you pick a number between these two or these two and plug x and replace x by it, it's going to be less than or equal to. That's all it means. Okay, we have time for a rational, and this is the end of the new material for test 2. So let's look at x plus 1, x minus 3 over negative x minus 4. Let's say less than or equal to 0. How many factors we see? 3 factors. X is the variable in the problem. X plus 1 is the next factor. X minus 3 is the next factor. Negative x minus 4, the last one. And what will always be the last row? The whole thing, exactly. I couldn't have said it better. The whole thing. So I'm going to say x plus 1, x minus 3 over negative x minus 4. X is the variable in the problem. What number will you give me for x plus 1 that makes x plus 1 0? Negative 1. What number will you give for x minus 3 that makes x minus 3 0? And for negative x minus 4? I put them on the side because they have to be arranged in ascending order, and I don't want to make a mistake. So first I write them aside. Perfect. So in ascending order from left to right, which number does go in the chart first? Perfect. The next one. Yes, perfect. And 3. In this chart, there is no need for x equals 0 unless we have a factor of 0. Good. So what do I write? Where do I write the 0 for x plus 1? Under Perfect. Where do I write the 0 for x minus 3? On the 3. Perfect. And where do I write the 0 for negative x minus 4? I know it's a silly question. It's the last one, right? Good. So now, what happens to the entire thing when x is negative 4? Careful, think. Careful. When there is a 0 in the denominator of a fraction, what do we have? That's what we have. When the denominator is 0, that's what we have. We don't have a number, right? We call it undefined. Yes. Very good. So it's undefined. Only because the denominator is 0 or could be 0. What happens under negative 1? Different story. What happens under negative 1? It's at the top. What happens if there is 0 at the top? Correct. And what happens when x is 3? Yes, it's at the top. Perfect. The signs for x plus 1, please. If you have any doubts, plug in a number. Find a number between these two and plug it in, and you'll see the sign. So, but negative 4 minus 1, it looks like this. It's a positive slope. Perfect. What about the second one? Yeah, same thing. Because it's a positive slope, same thing. Just plug in a number to the left of 0. And what about the last one? This one is positive and negative because it has a negative leading coefficient. The last one looks like this. So it's coming from, is that okay? Everyone with me? Okay, so now we have to identify, we have 1, 2, 3, 4 subintervals. We only count the negatives. There is no need to count the positives. So the sign on the first one. The sign with 3 negatives. Perfect. The sign with 2 negatives. Very good. And the sign with 1 negative. I don't know what to choose before I look here now. This tells me what to choose. What sign is less than or equal to 0? And there is only one sign that is less than or equal to 0. Negative. Is this expression ever negative? For these and for these. And that's the final answer. So that's how we solve polynomial and rational inequalities. So we have the answer x in the interval from, yes, why negative 4 open and not closed? Because it's undefined. Very good, awesome. Comma. This one is with the bracket because we have the equal symbol. And union, yes, 3 with a bracket because 0 is allowed. Any questions?